Hi everyone, Stefan. So let's just quick show of hands. Who's used Docker? Okay, that's good. Who's done continuous delivery or continuous deployment with Docker? Okay, so good selection. Okay, that's pretty reasonable. The presentation is just going to be a quick overview, kind of 20,000 for a few best practices, and yeah, we'll go from there. Why have you done to your laptop? Good start. Okay. So I'll start with a quick introduction of myself. We'll go over what KAYCEE's aim is very quickly, and then we'll kind of dig into continuous delivery, how it relates with Docker, how Docker improves continuous delivery, some quick kind of guidelines like foundational tips, nothing else, and then we're going to go into deployment types. And then we'll give a quick demo of our platform. Okay, so as you all know now, my name is Stefan. I've been working in IT for 20 years. I started as an MCSE way back when, systems administrator, solutions architect. I moved on to AWS and started working with AWS in 2008. I've been working on that platform pretty much every day since, so I've got my fair share of experience. I currently hold 4 of the available 5 exams for AWS, 1 being DevOps, 1 being the solutions architect. My love of all things is Linux, AWS, Bash scripting, and Python, and PHP, which I realise is not popular this side of the world, but I still love it, so it's all good. Okay, so our aim at KAYCEE, it's really just to support you guys, companies, to help deliver software out to companies or out to their customers quicker. We expect them to be adopting DevOps, everyone's heading down that line. Key for us in DevOps though really is continuous delivery. And there's a reason that's key. It drives a lot of the underlying benefits that DevOps comes. I'm sure some of the stats you can see at the bottom there, most of you have come across. If you're a high-performing DevOps team, you're publishing 200 times quicker than kind of low-performing teams. Your recovery time is far quicker. It's less than an hour in most cases. Your lead time from starting code and pushing out is also far quicker. As you can see, it's like 2,500. And then the failure rate is far less, considerably less, actually. So the question is, why do we think continuous delivery is key to DevOps? Firstly, the aim with continuous delivery is low-risk deployments. Constant, painless deployments of small amounts of code that go out without any issues. From the previous slide, this should be happening like several times a day. We kind of assume that to do continuous delivery, you need to be doing continuous integration. I don't touch that in this talk, but happy to talk about it after. There's shorter lead times. When you find out there's a bug, you can get it fixed within an hour, okay? This has its own benefits. Continuous delivery also drives higher quality. When your developers know that their code is going out into production, they develop it better. They think about it more, they spend a little bit more time at the front end making sure that it's correct, and then they push it out. This drives lower costs. It also drives a better product. The other surprising fact that I came across from some journal studies is that teams that are running continuous delivery have happier teams. Their motivations are far higher. The thesis really is that this is because they're seeing their results straight away. They're also directly speaking to customers and getting direct feedback on things that are going out. So they're instantly giving the customer what they want. Okay, so the other simple one, what's the difference between continuous delivery and continuous deployment? It's almost essentially the same. It's 90–95% the same. The difference really is on staging, you'll probably likely have an acceptance test at that stage. The acceptance test is it goes to the product owner, it gets reviewed, and then it's manually clicked through. Has anybody seen this the other way around and had the other way, like continuous deployment is the manual and continuous delivery? No? Okay. I ask because there's not a consensus on this all the time. Okay?
I can see why there would be, though, right?
Hmm?
I can see why there would be, right?
Yeah, there really should be. Continuous delivery and continuous deployment are so interchanged that it gets thrown down in a blog. This is the way we talk about it and the way we define it, and if you stick with one, then you're okay. Okay, so how Docker improves continuous deployment. Docker allows us to build immutable artifacts. Compared to something like Chef, Puppet, or general server builds, it allows us to build the application at the front end with all of the dependencies, it's the primary benefit of Docker, and then move that article through the pipeline. I still see a lot of companies that aren't doing that, even those that are leveraging Docker. We'll come onto this a little bit more as I go down through it, but that's kind of the first reason. Building it once and then moving it through gives us an increased robustness. It reduces our risk of failures along that pipeline, reduces blockage, the same going out to production. We also get, once we built it once, we can test many. We can retest that same image over and over again, and we should be. That's the aim of most of your pipeline. That image should go out there, we should test it. You should test it locally, then test it on QA, test it on staging, and then even test it in production. We get quick rollbacks. I mean, we had quick rollbacks previously, but they're far quicker. Again, we're talking seconds rather than minutes, which in our world is key. It also simplifies deployment. As many of you have used Docker, we all know that the Docker run command is great, simple. Same with the Docker service, and now the new Docker stat command that is coming out, or that is out in 1.13. It allows faster deployment. Again, this is kind of the same as quick rollbacks. We all know how quick it is, we've all used it. Once it's downloaded, we're good to go. I also think Docker gives us true server config as code. I mean, we kind of had it with Chef and Puppet, but that implied changes when we were building it. In this case, that image is literally coded. If we wanted to, I'm sure we could go in and manually change it, although we shouldn't. So it really opens that up for us. Okay. Any questions so far? I'm going to open up because it's easier for me, rather than wait until the end. No? Okay. That's good. I think I'm probably going too quick here at the moment, but we're fine. Yeah?
When you talk about the continuous deployment or delivery, how large are your code changes? Do you have some kind of metrics where, you know, there's a certain large code change where you can't easily run a regression test, and maybe this is more difficult to do and roll back versus, you know, many small? Is there something?
There's not a fixed unit on that. Really, you should keep it as small as possible. Obviously, in the real world, that doesn't happen. One of the guidelines that I'm about to actually pull up here is that you start to separate out how you break up your code. You decouple code changes from database migrations from infrastructure migrations. That has a knock-on effect. With some code changes, you're going to need to write the code first and then do the database migration. With others, you're going to need the database migration before you do the code. That's obviously dependent on the task. There's other solutions available that you can also implement, and we do quite heavily. It's kind of feature flagging and dark code deployments. That really is where you want to be getting your developers to focus on. You should be getting code into production that doesn't have a knock-on effect to anything else, and then moving on from there.
Where does pen testing fit into the whole race? Because are we pen testing that stage, and then once it passes the pen test, move it on?
Good question. It's open. There's many different takes on it. If you've got heavy, extensive pen testing, then I'd probably do it within stage just before you move to production. If you've got a lightweight suite that you can run quickly, then I'd do it as soon as possible. In all cases, I would automate as many of the tests as you can as soon as possible. One of the things about CD that you'll come to notice is the more you implement it, you'll notice that the same kind of tests create a bottleneck for you. If that is pen testing, because it comes up regularly, then move that test right to the start. So it fails soon and it gets back into that development loop before you move on. So it's open to interpretation, but yeah. Does that answer the question?
Yes, it does.
Yeah? Okay. So the guide. Again, as I stated, we're going to build it once. Within your CD pipeline, we should be leveraging the tag system within Docker. This is certainly how Kaalaman does it, and it's certainly how we found the most stability for deploying. Simply, as we say, we're not changing the artifact at all as we move it through. And we move it from one repository to the next. My last slide covers this in a lot more detail. As I covered earlier, decouple your code from database migrations and your infrastructure changes. Try and keep them as separate as possible and the code chunks as small as possible. Deploy the same way to each environment as much as possible. If you're running blue-green deployments in production, run blue-green deployments in staging. Now I'll give you many people and many companies should run a third or a fourth testing environment, and you might not want to for speed. You might not want to have to spin up a full stack or need to spin up a full stack for your developers to test it. You might want to do something along rolling updates, but at least do one other environment that mirrors production, preferably two. Okay? Pass the environment variables in at runtime. We should never be coding environment variables. We should be using the environment parameters within Docker. We shouldn't really be using the CLI, we should be using the API, and that allows you to pass in all your environment variables. This is how you're going to reconfigure each stage without drastically changing that artifact. Again, remember the aim being is not to change the artifact as it moves through that pipeline. Pen testing, any other kind of tests, automate them. What I don't see at the moment, and what I think the industry is going to see more and more, is moving tests into the build stage. There's no reason, if you're running PHP, you can't run PHP unit as part of your build and then pull everything back out and just leave the log files within that build. There's a couple of benefits to this, but one is you have a bad build, everything is there within that build that you need to get access to. It's not scattered. If you come back to it later on, then it's there. You don't have to go hunting for it, all your logs are in one place. The other thing is, if the build fails, it's just going to go right back into the loop and it gets straight back out. Whereas if you go into and push it to production and then it fails, you might have to, not even production, sorry, into QA and then it fails, you might have to spend time and block your pipeline before anything else can come through. Okay? And then finally, keep your stacks and environment as similar as possible. Now, if you're running massive web stacks on your production site, probably not going to want to do that in development and staging. But if you're running a CDN, run a CDN in staging. I mean, it's fairly basic stuff and it's fairly best practice, but be surprised how many companies I see that aren't doing that. They deploy to a single instance and then move on and say, okay, that instance works, let's deploy it back out there, even with Docker. And in some cases, what I also see is because Docker makes it easy to deploy, we tend to get lazy and avoid doing it the correct way. So I'm going to cover 4 major deployment types that we come across. Minimum in-service deployments, rolling application deployments, blue-green deployments, and AB deployments. They're kind of there's 2 subcategories here really, the application deployment and then infrastructure deployments. So minimum in service is kind of as it sounds. You specify the minimum number of servers that can stay up, and then you update the remaining percentage. So in this case, we're specifying that 2 servers need to stay up, and then we update T3, T4, and T5. Once that goes green, we switch over and we update the remaining 2. And then stage 4, we have a fully green stack. Now, this deployment has a couple of benefits. It has relatively few moving parts. You're just updating your application or making your code changes within it. It doesn't work so well for code change, for infrastructure changes. Obviously, you still have to tear it down. One of the key things is Swarm allows you to do this at the moment. If you've got 10 containers running, you can simply specify using the update parameter that it updates 6, and then it will do the remaining 4 after. Okay? However, to fully support this with continuous delivery, you need outside support and monitoring and health checks and orchestration. So checking for 404s, checking for log files, checking for end results, anything along those lines. Okay? This generally comes with no downtime. However, one of the issues here is that we are running changes on live servers. And so if it wipes out a server, you've got to spend the time to recover that server. Rolling deployments was kind of the next step after minimum in service. And rolling deployments is specifying a much smaller number and then updating the services in that quantity. It has similar benefits to the minimum in service. It can take a lot longer to do. It requires the same orchestration, and again, Docker Swarm supports it out of the bag. Typically what I see for stacks that are running 10 containers are like 20% updates for each one. Obviously this takes 4 or 5 times as long as it does to do the minimum in service one. It's a bit more complex. Docker support for it does only allow 2 things. If it sees a failure of the deployment container, it can either pause it or it can continue regardless. In most cases, someone's going to have to jump in to do something to backtrack and roll it back. Again, the support is only for starting the container. There's no ongoing support. And the orchestration, if your buy button suddenly stops working on that deployment, you're not going to know about it because the container's running, and as far as we're concerned, or as far as Swarm is concerned, it's up and running. And the last line, as I said, it's one of the least efficient ways of moving forwards. So the blue-green is the next one. This kind of moves us down the stack. We've gone from just updating the application to updating the entire infrastructure. This has been feasible for a very long time, or it's been possible for a very long time. It wasn't feasible prior to the cloud, and that was just the sheer cost. If you had 100 servers running for your production, you needed to spin up another 100 servers for your blue-green deployment. Well, when you're talking hardware, that's an obscene amount of money. Obviously with blue-green, the aim really is to get the stack up and fully deployed within an hour, 2 hours, and rolled over. With cloud costs, even if you're running 100, 200, 1,000, Those are still really low numbers for that amount of time. This has no zero downtime on both upgrades and rollbacks. Typically what we see is a DNS change for blue-green. This isn't the only solution. You can do blue-green with modifying auto-scaling groups. I haven't included that because personally I'm not a fan of how that works. There is reduced risk here, and that's because we're not affecting the servers. We're spinning up the same entire stack and moving forward. However, it is preferable with blue-green that you maintain and use the same database. So obviously if you've got something that's modifying the database and you kill your database, you've still got some risk there. But hopefully by the time it's been through all your staging, that's not happening in production. The other thing about blue-green is it gives us a larger validation window or testing window. We can spin up the stack and then we can do pen testing, or we do performance testing, or we can do application testing at that point. Once it passes all of those things, we can then do the switch over. It does have increased infrastructure costs, which I've already covered. It also kind of suffers from the zero to hero problem here. And this is quite simply that stack, even if you're load testing it, you're not necessarily giving it natural traffic. When you do the switch over, you're suddenly going to get an influx of all of your users moving to that stack. And at that point, you really don't want it to break. That brought on AB deployments. AB deployments are almost exactly the same. You spin up a new stack, but now rather than doing 100% switch over, we do a 20% switch over, typically again at the DNS level. So we can use something like Route 53 and AWS, do round robin and weighted and weight that. So we're getting 20% of the traffic through to the new servers. That way we're starting to kind of pre-warm it. It gives us all the benefits of blue-green. It also gives us some customer validation. If you're only moving 20% over, 20% of your customers are going to go out and test it. If for some reason they hate it, or if the buy button isn't working, you can monitor for that and roll back based on that traffic. That gives us a much smaller blast impact for any errors or any issues that go on. We can roll it back. We can gradually scale it up. You can go 20, 40, 60, 80. If you're happy with the 20% and it's working, you can jump right up to 100. But again, I would advise against it. The only real downside against this is that compared to minimum in service and rolling deployments, there's a lot more moving parts. It's a lot more complex. This really does require that everything is automated up to that point. Okay. So I've got a demo of our application and how we set up stacks and how it's deployed. It will take a couple of minutes. Any more questions before I move on to the demo? Yep.
Can we go back to the previous slide where you have this M database? If that's a relational database, I think if you have data model changes, you'll have like initially you have these different application servers right to different data models. From your experience, if I have a NoSQL database in the end, can you manage data model changes in the back end where you have multiple data structures depending on the version, the data looks differently and you can still roll back?
I see no reason why not. If it's NoSQL, I would assume it's slightly easier than a relational database where I'm going to have to change the actual structure. Again, it comes down to how you roll the code out more than anything else, and whether you need to make the change to support the new structure or make the database change first and then write the code. So again, it will really depend on the type of change that you're making. Yep.
So in this configuration, if I'm correct, S3 DNS, when it does weighted, is not a sticky change, correct? So I have a 20% chance of hitting the green server and 80% chance of hitting the blue server and any request that we get. Is that correct?
Route 53.
Oh, sorry,
remember-
Route 53, yeah.
Route 53, yeah, sorry, that's what threw me for a second there. I was like, I heard S3. Yes, potentially. In some cases. Memory serves, I think they now have a sticky option within Route 53. I'm not sure about the other cloud providers at the moment, but there definitely is some way balancing it.
So you can get a chance.
It also doesn't make too much difference as well because you're caching the response you're getting from Route 53, and so assuming the TTL isn't too drastic, you're going to hit the same load balancer over and over again. Typically that's where we'll definitely put some stickiness on there. Okay? Did I see another hand up? No.
Is there a reason that you specifically called out this using the multi-zone RDS, where the other one just kind of happens to run databases? Is that a fact?
I did not draw these diagrams. Doesn't really make a difference.
Okay.
Truthfully, I would never run non-multi-zone RDS. Any changes you need to make with a non-multi-zone RDS, your server's going down for a couple of minutes. Multi-zone RDS is going to stay up, so yeah, I wouldn't worry about that too much.
I mean, you could achieve the same thing with a load balancer instead of the DNS.
Yes, you can. You can do it with load balancers, you can do load balancer switch outs, you can also do auto-scaling configuration switch outs, which are all fine. I personally have a preference for the DNS. I just find it cleaner, my stack is cleaner, it's just my personal preference. There are times when you're going to need to do one of those others. I haven't covered it in this because we could go on for hours about it.
The only reason I mention is you have that sticky option with them. Typically have that sticky option with all the ones.
Yes. Okay. Now I'm hoping our demo works because we all know how demos go. Good start. Yeah, we did connect earlier. Yes. I did all of that. It was working. I was up and running. There's internet. I'm gonna.
You know what? Your laptop went to sleep before.
Of course it did. Okay. That's it. Yeah. Okay. I'm sorry, I didn't realize this one on. That one. Okay, we're running a little short on time, so I'm going to have to be as quick as possible here. This is our dashboard. Within this dashboard, you can see applications and application collections, and we can filter types. I'll just run you through our onboarding wizard and what that would look like. Basically, we allow you to deploy to Swarm. We manage all of the infrastructure and the Swarm deployments. All you guys need to focus on is your containers. So we come in and we'll add a collection. So let's do demo Docker. At this point, we're going to start outlining all of the containers within the application. There's no limit to how many you can have in here. If you've got some existing ones, which I happen to have to speed up my typing, you can come in and select those. I'll just show you what this looks like. Basically, you can set the basic parameters for your container. The number of containers that is going to run on that server or across your cluster. Any deployment commands that you want to run from outside your Docker file. The version numbers, the ports. We also have the environment variables. These can be both dynamic and static. Any of our models or anything that we link to. So if you connect later on a database service, we create a secure password and then no one never needs to get access to that. It's all piped in through the environment variables. And we just use that with the kind of standard curly parentheses, database one dot host dot password, anything like that. So you don't really have to deal with worrying about that anymore. Once you've set up your containers, oh, hang on, before I do that, sorry. You can also set dependencies. This is fully graphed out. So if you've got 50 containers and it requires that you run, I don't know, Redis in the case of the kind of cat and dog voting app, that needs to be up before the other container starts. You can specify that here. And we literally wait until that's up and running and we get an all clear, and then we move on and build out the containers that way. So at the next stage, we start to outline each of those environments. If you're more experienced, you can specify the environments yourself, but for those that aren't, they can just come in and select our default environment. Nope. Sorry, I'm not a Mac user, I'm a Linux user. We recommend a QA, a staging and production. That's fairly common across most people. You can edit the properties of this. This is currently missing a couple of properties. This is pre-beta, it's not even out yet, by the way. You can specify the size of the clusters and the number of masters within your Docker Swarm cluster. Everything else is linked in. You can specify the region. We also have the option to deploy into Azure. We deploy everything into your account, so you need to provide us with either your AWS keys or your Azure details, okay? So everything goes into your account. It's fully white box. You have access to the Docker Swarm. You can SSH in. You can do all the things that you want to. So it's kind of almost like the anti-Heroku in that case. You can specify other services that you want within your stack. Right now, we support basically all of the RDS instances that are available, and you can attach that. You can attach one to one stack, you can attach one database to many stacks. You can do many combinations, whatever you need to make it work, basically. And then you can do specification whether it's high availability or it's not. And then finally, the continuous deployment tags. We recommend, as we said earlier, you do tagging, and then we do a regex scan for those tags. So if you tag your Docker image into your repo as QA, we will get notified of that through the webhook, and then we will deploy that to your QA environment. When you're happy with that, you retag that image to staging, and again we do the same and we move down the pipeline that way. You have the option to deploy everything at that point, or you can skip it and go back through. I deployed some of this already. So we can come in, we can also see the stacks, and then we can see which actions have been taken on the stacks, whether the stack has been deployed, whether it's in a failed state. We can look at resources. Where's my deployed stack? It's that one. So we can see there was a launch action that took place on this. This was completed. We can deploy any attached applications here if we wanted to. We can go and take a look at the properties of each of the resources. If you haven't deployed your stack, you can go and modify these if you want to. It saves writing out your CloudFormation template or anything along those lines. Okay, and then you can simply collect the IP address and go and take a look at your actual deployment. This is deployed into Swarm, so it's across currently many stages. So I'll just quickly show you what's gone on here. Just to sign me out. Brilliant. JP, which one of these is it? First one, yeah? Thank God for last pass. Brilliant. I've got 2 more slides and then I'm done. No. Okay. This is the model for the cluster underneath. We've got an auto-scaling group for your master tiers. Currently that can be in 1, 3 or 5. It needs to be that way because master requires an odd number so it can correctly vote on who is actually in charge out of them. Below it, we then have the number of slaves. The number of slaves can be any number that you can put in an auto-scale group. You can have it as 1, and it will recover. You can have it as 2, and you can have it scale up to, I don't know, 10,000, whatever you want in there. We provision everything if you want, right from the kind of VPC network layer, right the way up to your stack, or you can specify your own network, your own VPCs, and deploy into that. This is kind of what continuous delivery looks like through us. As I said, you build it, you tag it, we get notified from the repository, we push it out. We send you a notification that that was happy. If you've got CI running, you then run your tests and do some more tests on QA. You retag it, you push it, and you move it through the pipeline. And with that, that kind of brings me to the end of the presentation. Any final questions for me? Yes?
You are telling that you are storing the API key of AWS and the secret. How are you storing it? So what is the chance if our InfoSec department asks us how are they stored and if a third party can get access to them?
A third party can't get access to them. It is all encrypted in the database at the moment. As I said, this is pre-beta. We do plan on adding the option so we can do cross-account access for AWS. That will probably be available, I would say, within the next month or so. Azure uses OAuth at the moment, so we don't store much there.